Okay, today we're going to look at section 10.4, evaluating inverse trig functions. By the end of the class, you should be able to evaluate inverse trig functions, use trigonometric equations and the inverse trigonometric equations to solve problems. You can take a look at the essential question there and figure out which trig function to use for that. Vocabulary. Inverse trig functions take in a trig function value and give you the angle associated with that value. In other words, it does the reverse of the trig function. A trig function, like sine or cosine, takes an angle as input and gives you the ratio of two sides as output. The inverse trig function does the opposite. It takes the ratio as input and gives you the angle as output. For example, if you have the ratio of the side opposite and the hypotenuse, then you could use the inverse sine to find the measure of the angle. Inverse trig functions are denoted by the -1 superscript, such as sine -1, 1/2. I will call that inverse sine of 1/2 equals theta. Another way you may see it written is the word arcsine. Those are synonymous. They mean exactly the same thing. So inverse sine and arcsine are exactly the same thing. Okay, they can be used interchangeably. The calculator has the inverse sine function on it. You won't find arcsine on the calculator, but you will find the inverse sine right above the sine function. Now, don't confuse that with the reciprocal. It is not the reciprocal. Okay, don't make that mistake. It's a very common mistake, but we have to get used to that. We already defined the reciprocal functions last class. So inverse sine is not equal to cosecant. Okay? Inverse cosine is not equal to secant. And inverse tangent is not equal to cotangent. So make sure you don't make that mistake. Okay, on your calculator, you're only going to find the inverse functions of sine, cosine, and tangent. Therefore, you must learn how to manipulate the numbers so that you'll get the info you want. For instance, if I want to take the cosecant, inverse cosecant of 2, I would have to type that into my calculator as the inverse sine of 1/2. Remember, I'm going to take the reciprocal of it. And if I plug that into my calculator in degree mode, it would come up to be 30 degrees. So make sure that you know how to do that on your calculator. Okay, so in this lesson, we're going to have a lot of uh, formulas and drawing and stuff like that. So if you don't get all the notes down right now, that's okay. You can come back and watch this video again and pause it where you need to make sure you get all the notes. So let's take a look at inverse functions, okay, to be used when finding the measure for an angle. Now, these functions only exist in certain quadrants, and that's because there could be multiple answers. Remember, we talked about coterminal angles? Well, there's an infinite number of coterminal angles. So when we do the inverse sine, we only want to get one angle. So if sine is equal to A, then inverse sine is going to be in quadrants 1 and 4, between -90 and +90 degrees, or in radians, negative pi over 2 to pi over 2. Cosine, if I want to take the inverse cosine, it's going to be in quadrants 1 and 2, between 0 and 180 degrees, and 0 and pi radians. Now, we'll talk more about this um, in trigonometry class next year to explain why exactly we do it this way. All right, and then tangent, inverse tangent, is going to give us in quadrants 1 and 4 again, just like sine. So between negative 90 and positive 90 degrees, and between negative pi over 2 and positive pi over 2. So let's take a look at how to do some of these. So let's take the inverse cosine of negative 1. So what angle would give me a cosine of negative 1? So if I think about inverse cosine, it's going to be between 0 and 180 degrees. Negative 1. Oh, my x value over here is my cosine, and it's at negative 1. So that would be at 180 degrees or at pi radians. Let's take a look at inverse sine of square root of 2 over 2. Here is my two axes. Now, I'm going to be either in quadrant 1 or quadrant 4, but this is positive, so we know it's going to be in quadrant 1. So, square root of 2 over 2, well, if I look on my unit circle, that's going to be at 45 degrees, or pi over 4 radians. Inverse tangent of negative square root of 3, well, I know that that's going to be in quadrant 4 because it's negative. Now, if I look here on my unit circle, I'm going to see that that's at negative 60 degrees or positive 300. But again, we're going to be going between negative 90 and positive 90. So we're going to use the value negative 60 degrees. And if I look on my unit circle, I can figure out that that's negative pi over 3 radians. Now, quite often, we're going to have values that we can't evaluate on a unit circle. We're going to have to use our calculator. Now, remember, you have to check your mode on your calculator. So if you click the mode button, if you go down a little bit, you'll see between radians and degrees. This is very important. It's one of the most common mistakes that I see in trigonometry is students are in the wrong mode. So practice these two with your calculator and see if you can come up with these answers that I have below here. So if I do inverse tangent of negative 1 and I do it in degree mode, I'm going to come up with negative 59 point whatever degrees. I repeat the process, but now in radian mode, I'm going to come up with negative 1.039. Okay. It's not going to tell me what that relationship to pi is. So we're just going to leave it like this as radians. Well, let's do the same thing for cosine. Cosine is going to be positive in quadrant 1 here. And if I plug this into my calculator in degree mode, I come up with 76.113 degrees. If I do it in radians, 1.328 radians. So I'll give you a couple of seconds to get these notes down. All right, and if you don't get all these, you can come back and view the video again. All right, one more time. Let's do it in radians and degrees. Now these we could do without a calculator. If we really needed to use a calculator to check, we could. But if you do it in radians, pi over 6 is not going to be obvious as a decimal number. So that's why it's good just to memorize your unit circle and memorize your ratios. Cosine, inverse cosine of square root of 3 over 2. Well, cosine of theta equals square root of 3 over 2. Well, I know that that's going to happen at 30 degrees, which is equivalent to pi over 6. If I were to look on my unit circle, I would see that my x value at that point would be square root of 3 over 2. Let's take a look at the sine, inverse sine of 2 opposite over hypotenuse. That doesn't even make sense. I could look all day on the unit circle, and I'm not going to find anywhere where my y value is equal to 2, so that's not possible. Inverse tangent of negative 1. Well, -1, that's going to happen here, down here at -45 degrees, negative pi over 4. I would have a ratio here of -1 to 1. And so start getting used to some of these ratios because you're going to see them over and over and over and over again in trigonometry class next year. Give you a second to get those down. Okay, we'll continue on. What is the measure of angle theta in the triangle shown? Okay, well, here I'm going to have to see what I have. Well, 11, that's my hypotenuse. To angle theta, this is going to be my adjacent. So I know that cosine of theta is going to be 6 over 11. Well, to figure out what theta is equal to, I'm going to take the inverse cosine of 6 over 11. Again, I'm not going to find that on the unit circle easily, so I'm going to have to use my calculator and round it to the nearest thousandth here. So degrees would be 56.944 and radians would be 0.994. So I would really suggest you practice these on your calculator to make sure you come up with these values the same that I did here. Okay, that's going to be very critical to be able to know how to do that on your calculator. So make sure you practice those. Okay, continuing on. All right. A painter needs to lean a 30-foot ladder against a wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? Well, if I think about it, here I've got 1/4 of the length. So if I want to think about that, 1/4 of the length would be 7.5 to 30, that ratio. So the base of the ladder would be 7.5 feet from the base. The length of the ladder is 30, but that's really not the important part. The important part is the 1/4 ratio. So we're going to take theta is equal to, now here's this adjacent over hypotenuse. So the inverse cosine is going to take that ratio of adjacent over hypotenuse and give me the angle. And the angle turns out to be approximately 76 degrees. When in doubt, sketch it out. I'll give you a second to get those numbers down. Again, I would practice these on my calculator to make sure that I come up with these same answers that I did here. All right. Use the inverse functions to find the measure of the angle, solve the equation for theta. So I want to find sine of theta is equal to -5/8, but I want to find it between 180 and 270 degrees. So let's take a look at how to do that. Okay, remember sine is going to be negative in quadrants 4 and quadrant 3. So if I were to plug this into my calculator, I would come up with negative 38.682 degrees, which is a valid answer, but I'm also going to have that same exact ratio over here in quadrant 3. And I have to figure out what that angle is. So my reference angle here would be 38.682, and I could add that to 180 degrees to get to my angle in this quadrant, and it would be 218.682 degrees. And if you took the sine of this, it should give you -5/8. So again, inverse sine, I'm going to have more than one place on the unit circle here that's going to satisfy sine is equal to -5/8. So my calculator is only going to give me this answer. I have to go manually figure out which one this is. Same thing with cosine here. I say cosine of theta is equal to 0.4. And I want to find that value between 270 and 360, so in quadrant 4. Remember, cosine is going to be positive in quadrant 1 and quadrant 4, but if I plug in inverse cosine of 0.4, it's going to give me a positive 66 degrees. Well, I want to figure out what that is in quadrant 4. So it's going to be the same reference angle, but now I'm going to subtract it from 360. And if I subtract that, it gives me 293.578 degrees. Again, if I plug that into my calculator and take the cosine of it, it's going to give me 0.4. So let me give you a couple seconds to jot those notes down. Okay. Again, if you need to come back, you certainly can get these notes off the video. But I do want to finish up here. So, got a couple problems here. I'm going to do them one at a time. It says solve for theta if tangent equals 2.1. Well, we want to do it between pi and 3 pi over 2. So we want to look at quadrant 3. Now, inverse tangent is going to give me an answer in quadrant 1 or 4. Now, I know that if this is positive here, that means in quadrant 3 it's going to be positive. So it's going to have the same reference angle. So if I take the inverse tangent of 2.1, making sure I'm in radians now, it's going to give me an answer of 1.126 radians. But I want to be in quadrant 3. So I'm going to take this reference angle here and add it to pi, which is approximately 3.14. So 3.14 plus 1.126 is going to give me the 4.268, which will be in quadrant 3. Let's take a look at number 2 here. I want to find sine of theta is equal to negative 0.25, and I want to find it in quadrant 4. Well, it's going to give me an answer in either quadrant 1 or quadrant 4, and since it's negative, well, that's the angle it's going to be. So, but look what happens. When I take the inverse sine of negative 0.23, it's going to give me negative 13.297 degrees. But I want it between 270 and 360. So I got to come all the way around the circle here and add 360 to this. So I'm going to have the same terminal side, but I want to add 360 to it. So 360 minus 13.297 is going to give me 346 degrees, which is in the range that I want. Take a look at number 3 here. Sine of theta is equal to 0.62, and I want it to be between pi over 2 and pi. Remember, inverse sine is going to give me an answer in quadrant 1 or 4. And if I take sine of 0.62, it's going to give inverse sine of 0.62, it's going to give me 0.669 radians. But that's in quadrant 1. I want to find it in quadrant 2, so I'm going to take the same reference angle here, and I'm going to subtract it from pi. So again, pi is 3.14 minus that reference angle, 0.669 is going to give me approximately 2.473 radians, which is going to be this angle here. Okay. And finally, number 4 here. Cosine of theta is equal to negative 0.39, and I want to find it between 180 and 270 degrees, so I want to find it in quadrant 3. Inverse cosine is going to give me my answer in quadrant 2. So inverse cosine of negative 0.39 is going to give me approximately 112.955 degrees. But I want it in quadrant 3, not 2. So I need to find this reference angle. So I could subtract 112 from 180, and that would give me my reference angle of 67.046. Now I can add that to 180 to get it in quadrant 3. So here I've got 247.046, and that's within the range that I want here. So a little bit tricky, a lot of thinking about the reference angles and things like that. So you might want to come back and revisit this slide in your notes to make sure that you understand everything that's going on this page. But I'll give you a second to get all these notes down. All right, and I think that's everything. So we're going to do the homework that's listed there. Here's some Alex suggestions. So we're going to stop the video here, and if you need to come back, you can find it on the class page under the today's lesson. So, all right.